Alright, so we're starting a new section right in this video. We are going to be talking about polynomial and rational inequalities. We know right now we know how to solve the really basic inequalities like x plus 2 is greater than or equal to 5 or something like something nice linear. But when we have terms like x squared or x cubed or 3 plus x over x squared minus 5, those are what we call polynomial and rational inequalities. And we've actually done a little bit of this already in the last section when we were graphing rational functions, because I said as part of finding where the graph was above and below the x-axis, you had to find, that was essentially determining the sign of the rational function. And to do that, you make sign charts. And the basic thing of the key to success in solving inequalities is knowing these fundamentals and basically knowing how to do sign charts. Because if you do a sign chart correctly, you can basically read off the solution to an inequality right off the sign chart. Okay, before we do that, we have to do some basic make sure we have some basic fundamentals. The first part, hopefully you already know that a positive times a positive is negative, or positive, check that. And if we have a positive times a negative, or a negative times a positive, we get a negative, and then a negative times a negative is a positive. Okay, so we should know that. The next thing is you should be able to make we're going to be interested in making sign charts of some basic algebraic expressions where we just have an expression of degree 1, or we have a power of polynomial of degree 1. Okay. For example, if x minus 2, I think we can agree that this is 0 at 2, and in fact it will change signs at 2. Okay, because if we wanted to, we could go ahead and, if we wanted to find when is x minus 2 greater than or equal to 0, well, that's going to be certainly when x is greater than or equal to 2. So we have, so we can see, and conversely, we can see that x minus 2 is negative when x is less than negative 2. So this goes from negative to positive. If we have an expression like 3 minus x, that's going to be reversed, because if we wanted to find where that is positive, let's say we can add x to both sides, and we see that will be positive when x is less than 3. And we can sort of see that if we plug in, let's say, a number over here like 0, we'll get something positive. If we plug a number over here like 4, we'll get something negative. Okay? So when it's 3 minus x, we go from positive to negative. Other things we want to be able to do, anything squared is always going to be positive, right? So it doesn't really matter what x minus 1 is. When we square it, it's positive. So it's positive on both sides of 1. X plus 5, of course, that will change sign at negative 5, right? Because this is 0 at negative 5. Again, if you wanted to see where this is positive, you can add negative 5 to both sides and see that it's x when greater than negative 5. So this goes from negative to positive. And then x minus 4 cubed. We really don't, because 3 is odd, the sign of this is going to be the same as the sign of x minus 4. When x minus 4 is negative, x minus 4 cubed is negative, right? So this, we can see that we can really just do a sign chart for x minus 4, and we see it goes from negative to positive. Now, once you know how to make a sign chart for expressions of this form, we can make a sign chart for more complicated polynomial functions. Like if we wanted to find a sign chart for the function x minus 2 times x plus 5, all we have to do is really find the sign of each factor. Okay? Because then we can say, let's say if we know that this is positive and this is negative, then the product's going to be negative, and so on. Now, there are a couple ways you could do this. In both cases, you want to find where each factor is 0. And so it will be, if you set this factor equal to 0, you get x equals 2. If you set this factor equal to 0, you get x equals negative 5. Okay? And so these are the only possibilities where the function will change sign. And so we certainly, the sign chart for this function will look like this. And what we could do is, before, we could plug in pick a number in this interval, pick a number of this interval, pick a number here, and plug it in here, see what the signs are. Or we can just take the sign charts for x minus 2, which we made above, and we said that this goes from negative to positive. X plus 5, that also goes from negative to positive. And then we can see what happens on all three intervals. On this interval, we have a negative times a negative, that's positive. Here we have, on between negative 5 and 2, we have a negative times a positive, that's negative. And when x is bigger than 2, and from 2 to infinity, we have a positive times a positive, so that's positive here. Okay, so there's the sign chart for this expression. Okay. We can make a similar sign chart for this function g of x. We've already made a sign chart for 3 minus x, and we have a sign chart for x minus 4 cubed. Okay, and again we can see that the place of this is 0 is going to be at 3 and 4. This goes from positive to negative. This goes from negative to positive. Okay, that's again from what we did up here. And then to make a sign chart for g of x, here's 3, here's 4. On this interval we have a positive times a negative. Here we have a negative times a negative, that's positive. And here we have a negative times a positive, and that will be negative. Okay, so there's the sign chart for g of x.